A 135-kilogram satellite just left New Zealand to test the space gas station. 9 months holding liquid oxygen at minus 183 degrees Celsius. Pass, and orbital fuel becomes a business, not a government asset. Every deep space mission, civil or military, will one day queue at somebody's pump, whose hand should be on the tap.
Let's get into it.
In 1913, the first drive-in petrol station opened in Pittsburgh, and the motorcar stopped being a curiosity. This month, the same threshold arrived in orbit. This is the Hamberger Report. I'm Andreas Hamberger, Enterprise Architect, Wellington. On the 17th of July, an Electron rocket lifted off from Launch Complex 1 on the Māhia Peninsula on the east coast of the North Island. The payload was AlloCSat-1, a 135-kilogram satellite built by Eta Space, a Florida aerospace company, under a NASA tipping point contract. It rides on Rocket Lab's Photon spacecraft bus, which will keep it oriented and talking to the ground for the next 9 months. Last week, this channel covered a launch from the same site that was all about speed, noticed to liftoff in under a day. This mission asks the opposite question. Speed is the ability to deploy fast. Fuel is the ability to sustain what you deployed. Every deep space ambition on the books needs both, and until this month, nobody had flown the end-to-end test that makes the second one possible. That test is now overhead. The problem with a gas station in orbit has never been the idea. It is the fuel itself. Liquid oxygen sits below minus 297 degrees Fahrenheit, and without gravity to settle it, it behaves in ways that are hard to predict. Inside a tank, you cannot easily tell where the liquid is. You lose mass to boil off as it warms. You have to move it through a sealed coupling into another spacecraft without spilling or venting a drop. Get any of that wrong, and the depot drains its own tanks before it can sell anything. LOXSAT will spend 9 months in low Earth orbit, demonstrating 11 separate technologies against exactly those failure points. Storage that holds oxygen without venting, gauging accurate enough that the depot knows what it actually has, automated pressure control, and cryogenic transfer between spacecraft. Trade coverage has called it the most complete single satellite attempt yet at end-to-end cryogenic fluid management, and the framing is fair. This is the test that replaces laboratory approximation with real orbital data. NASA has backed the work with roughly $52 million across 2 tipping point contracts. The bet is that the physics can be tamed. Here is the economics in one image. To send a Starship lunar lander to the moon, it has to be refueled in low Earth orbit first, because it burns most of its propellant just getting off the planet. How many tanker flights does that take? Trade coverage puts the consensus somewhere between 10 and 16 launches, depending on the mission profile, and I give you the range deliberately, because the precise figure has not been pinned to a primary NASA document. The exact count is not the point. Every one of those tankers has to deliver propellant to something that can hold it. Without a depot storing cryogenic fuel at near zero boil-off, the whole architecture is hypothetical. The downstream product is called Cryo-Dock, Eta Space's planned commercial depot, targeted for low Earth orbit by 2030. Notice the word commercial. Cryo-Dock is not a government asset. It is a business built to sell fuel in orbit to anyone with a compatible spacecraft. Who gets to be that anyone is a sovereignty question. And on Friday, the 28th of August, this channel launches its permanent open source series, Free as in Theft, which takes the same question up from the software side. Subscribe so it reaches your feed. The part of this story that should hold a strategist's attention is not the tank, it is the plug. The cryogenic coupling on LOXSAT was built by Altius Space Machines, a subsidiary of Voyager Space. Altius developed a disconnect and latch mechanism that lets a depot connect to a client spacecraft, transfer fuel, and release with no human involved. If that coupling becomes the interface every depot and every client is built around, it is the orbital equivalent of the standard fuel nozzle. The company that sets the standard for how spacecraft refuel sets the terms of the orbital economy, the way whoever set the USB connector shaped everything built on top of it. A spacecraft that wants to refuel has to carry a compatible port. Whoever owns the port owns a toll booth on the road to deep space. That is the core argument of Space Māhia. A propellant depot is not a broadband service with many providers. It is infrastructure every deep space mission, civil, commercial, and military, will eventually depend on. That makes whoever controls validated cryogenic storage and transfers something closer to a utility than a vendor, and nobody has decided who regulates its price, its access terms, or its security. Every fuel stop has two possible futures. One is a multi-user depot with transparent access terms, open to any nation or company with a compatible spacecraft. The other is a depot whose tap can be granted or withdrawn by a single government. A depot governed by export control rules is, from a small country's point of view, one policy decision away from a closed tap, and there is a defense layer worth naming plainly. The United States Space Force now treats orbital logistics as a warfighting requirement. Through Space Systems Command and its Space WRX innovation arm, it has called on industry for in-domain orbital logistics, bulk and retail propellant, spares and repair, delivered at forward orbital nodes to sustain in-space maneuver. A satellite that can refuel is a satellite that can keep maneuvering, and maneuver is the currency of a contested orbit. That turns a fuel depot from a commercial amenity into strategic infrastructure. For the country that provides the launch ground for the first orbital validation of that infrastructure, the sovereign question is not who owns the depot in orbit, it is who may task the capability that lifts off from New Zealand soil. The low access set is not the only entry in this contest, and the field is more advanced than most people realize. 4 distinct players are already moving, split across 2 different fuels. Eta Space is the cryogenic beta, liquid oxygen and methane for the Moon and Mars class of vehicle, with Cryo-Dock targeted for 2030. Orbit Fab is further along commercially, but on conventional satellite propellant. Its published price is about $20 million United States dollars for up to 100 kilograms delivered to geosynchronous orbit, and it put a depot into that orbit in June 2026, alongside Astroscale, the Japanese servicing company that draws fuel from it. Then there is China. In May 2026, it launched an experimental satellite, Yuxing 306, described by state media as its first commercial satellite with a flexible robotic arm, carrying out simulated refueling tasks, the beginning of what it called mobile gas stations in orbit. And SpaceX sits across the whole picture. Its own ship-to-ship transfer was expected during 2026, though that remains planned rather than confirmed. If it works, its tankers become their own closed supply chain. Cryo-Dock's pitch is the opposite, an open depot any operator can use. So what does New Zealand actually hold? The first end-to-end validation of the deep space fuel stop flew from a headland on the east coast of the North Island. That is not a small thing, and it is worth being honest about what it means. Māhia gives this country the launch jurisdiction for the opening test of a technology that could become the backbone of the deep space supply chain. Rocket Lab, New Zealand founded and United States listed, supplied the launch and the spacecraft bus, and when Cryo-Dock needs a bus in 2030, the same company is an obvious candidate. And yet the depot is a United States company's product under a NASA contract serving an architecture built primarily for the United States program. New Zealand supplies the geography. From the 29th of July, the Ground-Based Space Infrastructure Act requires operators of ground-based space infrastructure here to hold authorization, and Launch Complex 1 is the most significant example in the country. So the test proves the storage, the coupling sets the standard. New Zealand is the ground, which leaves the question the country will have to answer for itself when the fuel stop for deep space is built. Do we want to be the launch pad it flew from, or the hand on the tap?
That is the Hamberger Report for today. If this was useful, subscribe and hit the like button. It helps more professionals find the channel. You will find links to everything we covered in the description below. I am Andreas Hamberger, and I will see you tomorrow.
Like and subscribe.